Okay. Yes.
Okay.
It tells me.
Great.
This meeting is being recorded. Okay. Yep. Oh.
Okay. I think we're giving folks a couple of minutes. So welcome. My name is John. I'm from the University of Michigan. This is the first, hopefully, in a series of Pulseq user group meetings. This I'll let Maxime chime in there, but I think this is not meant to be like a top-down sort of dictation of what to do. We want this to be interactive and informal. We do have a couple of presenters lined up who I hope will join us. At least we have Robert here. But other than that, and we'll talk about that as well. We can, the format of this is really open, and we want you guys' feedback as well. I can sort of step through a few agenda items, but Maxime, is there anything else you wanted to mention?
It's pretty much what we discussed before. Basically, would like to have this kind of a regular discussion exchange platform so that people don't have to wait for the big conferences to bump into me or John or whatever to let us know. And again, to lower the threshold a little bit for you to give us feedback. On the other hand, also for us to be able to share what's coming up and also to basically build more of the community. So people who are contributing projects on harmonized MRI are very welcome to also contribute talks in this forum and basically share their views, share their projects, share their findings and challenges maybe. And we'll see how it grows and flourishes, say, right? So thanks, Robert, for agreeing to be the first test case of the user presentation. I think we can start, right?
Okay. Yeah, so let's just step through. So see if I can share my email or share my screen. Hope everyone can see my screen. So you got the email. So there's this user group that we want to give a try. And I know that some of us have done a little bit of this kind of meeting, kind of informally, but we want to make this more public. And it doesn't have to be this. We can also form sub meetings and so forth based on vendors and whatever is useful. So it's really just to sort of start the conversation. So this is the agenda that I mailed out. So I'll just say a little bit about who we are, and we call ourselves the Harmonized MRI Group. And again, this is just sort of what I think is kind of a critical mass of folks, a subgroup within the broader Pulseq community. It doesn't, we don't, no one owns Pulseq, right? Can I say that, Maxim? Like what we're doing here is bigger than us or this meeting. So I just want to make that clear, but hopefully what we've done helps to kind of coalesce things a little bit and guide things forward. So that's the idea here. We'll give some Pulseq updates, or Maxime will, a little bit on the interpreters, just the status of that. And then we'll have two presentations, so focusing on projects that have been posted already on the Harmonized MRI's GitHub site, and I'll talk about later. And we just invited two of them that we thought sounded really interesting, that would be interesting to everyone else. And then we're just going to open up the floor. So that's the format. And again, this format is is fluid. We can certainly do something else. So this is the recently updated list of funding sources that are funding kind of the core team at the moment. Hopefully this will be expanded and changed. No matter what the funding is, we certainly hope that the vendor agnostic programming will continue into the future. So Harmonized MRI is basically a loose collection of essentially some of these PIs. And the last one is a very recent addition that I have to announce. So hopefully we'll expand a little bit on the Python side as well. And again, this project is not, is not limited to to the activities that are funded by these things. But that's, just to say that there's some hard money here that's kind of helping us develop some of these things. So we have a GitHub page that have also a relatively loose collections of a few projects and tools. For the community, we set up this website, and let me switch over to show you what that looks like if you haven't seen it. So this is a website where we'll post some announcements, and it allows users to upload a Pulseq project. So if you have a cool Pulseq project that you think is ready to be shared or that would be of interest to others, fill out the Google form, and we'll get an email and take a quick look, and then it'll be automatically be approved, and it'll be populated in this list here. And you see, it's already a list of some really cool projects. Folks are really taking this in a lot of different directions, and hopefully you can either use it as is or use that as templates for your own projects and inspiration. So that's that. Oh, I should mention, so this website, we set that up with some help from Ryan Zurin. He since left MGH. So I would love to have some help here. If there's someone who wants to be the webmaster for this, this is an opportunity to help out. It's working well as is, but there's going to be some maintenance in the future, and I don't have the skill to really do this well, and I don't want to break anything. So just want to mention that. Yeah, the mailing list, you saw that in the email. So we just set this up. We think it works. This is hosted by MGH. Try it out. We can also, as we use this, I'm sure we'll kind of find out how to best use it. There's already, as you know, a discussion forum for Pulseq that's quite active, where you can post technical questions. The mailing list you can also use it for that if you like. But mainly, I think we envision that as a way to communicate announcements and maybe more general philosophical questions, whatever you want. So that's the main idea about that behind that. So as far as this meeting, yes, we want this to be informal. I hope we can keep it like this, like a regular Zoom meeting. I find webinars to be a little kind of boring and not that conducive to an exchange of ideas. But let's see how it goes. I think the topics that I think some topics or content items that I think are useful. Obviously a Q&A discussion. Maybe if you want to see demos of specific features or workflows. If you have found something that you think others could learn from, some tips and tricks, that's great. We'd love to hear it. Yeah, user presentations, we think this is maybe a nice forum for folks to share some aspect of what they're working on, beyond just sort of the formal conference presentation, let's say. I'm working a lot with G users. Perhaps if you think could be beneficial to have either breakout or separate meetings that's specific to each vendor. There's probably enough activity for that, so that could be a possibility, and then anything else that you want to see. So you can either during this meeting or by email we can follow up on this. But this is basically the idea. So we're thinking once a meet for an hour, and then take it from there. Just very briefly on the interpreter updates, maybe I'll just start on the GE side. The big kind of change going forward there, in addition to the sort of community interpreter that's now open source, that's been contributed to by a few different users. GE now will host this in the future, so that source code will be moved onto the GE GitHub site. And I set that up. I need to port that code over. And in addition, so that's the last item there for the community version. In parallel with that, they have announced that they will take the community version and build an official product version that may or may not look like PGE2 in the end, but it is something that they have announced. So look for that, ask them about that, and hopefully that will happen going forward. Yeah, just a few details. It's not super important. I think maybe the folks that are using Pulseq on G anyway, they know about this, but the rotation events are really important, and I would really urge everyone to use those going forward for any kind of any rotation, because it really makes it robust and accurate. And there are some other details here that maybe are not super important to mention right now. I'm currently working on adding porting some of the PNS checks and acoustic safety checks that we can do now in MATLAB to the interpreter itself, as well as supporting arbitrary FOE placement, which existed in the old interpreter, but we have to port it over. I think if you want to get involved, you can help test new features. For example, I put up some examples sequences here. So testing those, updating those to the latest version of the interpreter, so forth. I think there's lots of opportunities there if you want to get involved. That's it for the G side. I don't know if anything you want to say on the Siemens side.
Well, yes, I think on my side, maybe if you stop sharing, I can share. And I actually didn't focus so much on Siemens. It's a mixture of like MATLAB new features and some of the Siemens interpreter, or not only just interpreter, let's put it like that, interpreter news. So if I share my screen, I have 4K display. I hope it's not breaking the Zoom connection. I sometimes have problems with that, so we'll see how that goes. So just talking, I've seen that. So basically, I was going to just fly very quickly through the slides deck, which I have, slides deck, which I have there, as always, way too many, but I just want to make sure that we have shown that once and that people have seen it. So one thing you've certainly seen this slide showing up. Previously, we have a new addition here. We thanks to contribution from Matt Budde from Medicine, we are now reviving the Brooker interpreter again. It's still experimental, but I'm pretty sure we'll have a lot of progress there. So that's something that's probably the biggest news of the year for me, because many people were asking us about Brooker support in the past, and I think it's great that there's some changes. And again, it's also great that it's a community contribution and not something which we would otherwise be having to do centrally. Another thing that I wanted to note that on Siemens or in general in all Pulseq files have this hash generated to them. And on Siemens interpreter in the newer version, if you use it, if you look at the sequence name and see the exclamation mark next to the sequence name, you know that the check of the signature actually failed. So the sequence is not original. It was manipulated after it was exported from MATLAB or Python. So it's there is now a built-in check which ensures a greater reproducibility. And we also include this hash, but actually not the hash which is calculated, but the hash which the sequence provides into the raw data. So if the file was manipulated, still the original hash would be piped through the raw data. And in practice, we actually like to save the data together with the sequences so that we always have the sequence and data pairs. So now back to MATLAB features, we have very exciting new features. We have this stacked plot, which is more kind of typical for sequence development environment, where all 6 plots are stacked one under each other. And we also have this hairline, which is now shows some quite useful information on the underlying objects. However, for very long sequences, this is still maybe slow. So we have another function which was actually primarily developed to produce illustrations for your papers. That's why it's called paperplot. It produces something which you can actually copy and paste directly into your paper or an abstract just by adding the labels of which axis is which, whatever. In your font of choice, you can already have a pretty useful sequence diagram. Sometimes you have to reduce the image resolution or whatever, that you can nicely see things, but it's really save times in terms of drawing those objects. And also it's actually faster to plot large sequences. That's another advantage of it. Now on the plotting side, we now also plot trigger events. That's basically both the digital output pulses, the triggers which are sent from the scanner to the outside world, are plotted as this diamond with a dot, and the dash shows the duration of the trigger if you see my mouse. And if it's a cardiac sequence, you also have the triggers where the sequence stops and waits, also the internal triggers in the sequence, or input triggers as we call them in Pulseq. They are shown by this triangle with dot. So dot is a position of the trigger, and triangle shows kind of run again logic, or tries to kind of present that. If you are integrating your sequences with the image recon, you need to use labels. And if you use labels, you can also plot them either in the traditional plots by providing additional flags, which labels you want to plot, or you can plot the evolution of all labels by first exporting them using this eval labels function, and then using the normal plotting MATLAB plotting functions to actually plot the evolution of the labels. It's not terribly new, but not many people know about it. We have the option, the demo code for analyzing this mechanical spectra of the sequences. This is done in this unsorted demos gradient spectrum, and we didn't move it to the final functions because we're still a little bit unsure how this needs to be done properly. So again, any input, scientific kind of input is welcome. So please have a look and tell what you think. For Siemens, we can actually also plot the forbidden frequency ranges directly on this plot if you have the corresponding data. So that's very, very useful for checking your sequences before going to the scanner. And also we integrate with this safe PNS prediction, and also the Pulseq has actually integrated safe PNS prediction code, which is based on this code, and we can nicely plot predicted PNS, also predicted cardiac nerve stimulation on CIMA-X. That's actually a new bit, which again, not many people know about. For this to work, also you have to export the corresponding data files from your IDEA or from your scanner, and the instructions for that are in the manuals. We have some new options for field of view positioning, thanks to Mushtaba from my group. They're now really easy to use. You can basically in your MATLAB code, you can generate the field of view transformation. You say you want to apply translation and rotation, and you can apply it to the entire sequence. So if you have an API, for example, you can rotate the entire sequence and shift it. You see the phases are changed, the gradients are mixed together. So it's already possible to test this on your console. For instance, if you want to investigate the influence of rotation on PNS or whatever, but you can also take the sequence and run it on the scanner, which will already have shifted field of view. So, and there are options to apply this either to the entire sequence, to the part of the sequence, or block by block, basically. And you can also use these options for creating single blocks or part of the sequence, for example, to accelerate sequence development. If you program a single slice sequence like single slice API, and then you can basically translate the same slice in Z direction to produce the multi-slice sequence, or you can do things like blade imaging, the propeller imaging. You basically program one single blade, and then you rotate it to add more blades. So there we have some examples on that. Here's an example of the blade sequence. We have a single blade, and then after we've rotated it, that would be the final sequence. You see, it's basically the copy of the same thing rotated multiple times. Okay, needs to be updated a little bit. We also have in MATLAB now some integrated data simulation tools. I know they were partly available in Python, but now we have in MATLAB 2 prototype functions. That's why they leave on the demo unsorted. One allows to simulate data with MR0 and another one with comma with the block simulator. You need to have standalone installations of those tools. But then if you have them, you can basically directly from your MATLAB run the simulations and also reconstruct images directly in MATLAB. And that's some simulations with basically with both tools. For now, the simulations for the simple 2D slice run somewhere between 3 and 30 seconds on my laptop on different computers, and for different data sets, they can, of course, take different time. So here's another simulation. You've seen we generated this blade sequence, and we can also nicely push it into the simulator and get the image, which has also typical characteristics of this semi-radial little bit of blurring in the image recon properties. So now about few extensions. Again, it's since summer, actually previous summer, that we released the soft delay extension. I haven't heard of many people using, so I'm trying to kind of popularize it also here. What it basically means, if you have any pure delay block in your sequence, you can actually turn it into something which will be later changeable. So basically, it needs to be a block which contains no gradient or RF event, and in the original sequence, it needs to have non-zero duration. And if this is the case, you can add the soft delay extension, and that will allow you later to modify the duration of this block. The soft delays, they identified by the numeric ID and the text hint. So this combination of these two IDs allow you, for example, to create soft delays with different logic. I'll show you in a moment. For example, for controlling echo time in a spin echo sequence, you have to add two delays, which will be both proportional to TE, but in different ways. And you can do that with this extension easily. So basically, the soft delay has this offset and factor parameters as well. And for example, if the spin echo sequence we can provide, we would like to basically specify the center of this ADC point by changing the delays of these two delay blocks. These are the two soft delays, and we have slightly different calculation rules for those. Basically, they both based on the half of the echo time specified by the user, but then the other bits are different. And we can basically provide this offset and factor parameters of the soft delay to realize this logic. And if we want to implement a multi-slice sequence and have TR, we can have the factor is apparently number of slices, and the offset is the actual duration per slice. Then any additional delay will be basically added on top of that. And if you want to mix TR and TE adjustments, actually a little bit more complicated. I don't have time to explain it, but basically you have to make sure that your core part of the TR never changes the duration independent of the TE, and that requires you to add a dummy delay which will change its. So if you make your TE longer, then this delay will get shorter to absorb the change in the TR, such that your TR will not change. And if you can realize it like that, then you can basically have both TE and TR adjustable. But actually, the main logic and the main use case, the main motivation on our side to implement it, was to provide subject-specific cardiac delays in the cardiac function, cardiac sequences. And again, whoever is working with cardiac, please try it out and let us know if it works for you. So on the sequence side, the soft delays appear in this box on the bottom right. You can define up to 4 soft delays, and they will appear with individual names in the tooltips. Basically, that's how it's implemented right now. Okay, that's how I mentioned already. Actually, I don't know the status of the Pulseq. I think people work on that, but I don't know whether this is already functional or not. And the final extension I wanted to highlight.
It is available. So we
Okay.
merged it like last week, I guess.
Oh, excellent. That's great news. Okay, and the last thing I wanted to highlight was the RF shimming. So we now have a possibility to specify channel-wise RF scaling as a complex number, and this is done per block. So blocks which contains RF, we can also add this RF shim extension, which basically defines a complex vector. It's actually up to you to know whether your system is 2-channel, 8-channel, or 16-channel. So this checks whether the sequence is compatible with the hardware will happen at the runtime, and maybe if you try to run an 2-channel control on the 8-channel system, there will be some incompatibility. So we're still learning how to use it, but we tested it on our 2-channel parallel transmit system, and you see by changing the relative phases of different channels, you can basically change the modulation pattern within the RF, so RF homogeneity. And now also in cooperation with Birkin and Bastien from MGH, we submitted an abstract where we had a possibility to test it on 8-channel 7 Tesla parallel transmit system. Here's an example of the single channel operation. Basically on the top you see your resequence when we basically selected the single transmit channel by manually setting the shim parameters in the user interface of the scanner. And with Pulseq, you can do the same now from a single sequence. It will basically go through possible channels. If you repeat this acquisition 8 times with different shim vectors, you can select single channels basically fully automatically. And here a demonstration that actually also works in vivo with Tiamo excitation, where you use 2 modes. Both of them have a complementary hot and cold spots, and by combining the data, you can actually get very nice homogeneity. So, oh no, I saw that actually wasn't the last extension. The last extension I wanted to highlight, the already mentioned rotation extension. And I've heard many people also like to use it and like it a lot. Once again, I don't know the status of the Python support for it, but basically we now have a possibility to add rotation metrics or quaternion for every block, and that allows for tremendous decrease in the complexity of the sequences, especially if it's like a 3D multi-shot, for example, cones or whatever sequence, where you actually repeat the same trajectory but with many different orientations. Now the sequences can get much more compact. They load way faster. They run much more stable, and we're basically very happy about that. So, in conclusion, so we have lots of new features which provide better RF and gradient support. Actually, through that, we have more accurate k-space calculation. The rotation extension is really great for non-Cartesian sequences, and the RF shimming and the soft delay extensions, they're also new kits on the block, which we would like to see how they are used. What we're working on right now and hope will probably finish somewhere in December or January is that we would like to integrate this field of view positioning, which is based on the explicit recalculation of the sequence, which we for now do in MATLAB and Python. Would like to implement it also as a feature directly into the Siemens interpreter to allow for more accurate field of view positioning for non-Cartesian sequences, or also work around this bug which Siemens have for nuclei other than protons, that the current field of view position basically is not working. So that's it for now. I think I'd thank all the people who contributed to our work, and we open for discussion. So maybe I would let John finish his part.
Yeah, no, that's all I want to say. So thanks so much. So the next item were the 2 presentations, but actually we have maybe a question in the chat. Do we want to? the question for, I think, Matteo. Do you want to comment on the rotation, on the support for the rotation event and apply Pulseq? Anything you want to say, Matteo, about that? Or we can just do it in the chat. It doesn't matter to me.
Oh,
All right.
well,
I guess
I
it's
don't know,
okay.
but Matteo did.
Yeah, knowing him, I bet we
Matteo, we
can
can hear
rest
you.
assured that it's supported well by Pulseq as well.
Yep.
So I think we can do the presentation. So we suggested 10 minutes each. So if you can try to keep it to that, that'd be great. So Robert will talk about PulsePal, if you don't mind starting, and then Yuting, if her internet connection is stable enough, she will talk about the MIMOSA. Okay, go ahead, Robert.
Sure. So first, let me just confirm if everybody could hear me. Hopefully my volume's coming across.
Yes, very good.
Great. So I think I'll just share my screen if I'm able to do that here. I'll try that right now. And I'll try to keep the 10 minutes. There's a lot I want to say about this topic, of course. There's a lot of stuff going into it, but if at any point there's a question, feel free to interrupt me or talk to me afterwards. I'll also have my PowerPoint not full screen because I'll be showing my browser later, so just bear with me here. I'll be talking about some of the work that I've been doing. This is more of a passion project, not really my main goal, but there's been some interest in this recently, so I'm happy to talk about it here. Right now, I have PulsePal pigeonholed as an AI assistant for Pulseq. I think it can do much more than that, but this is just currently how I present it. So for those that are unfamiliar with PulsePal, I'm just going to go into a little bit of the background first to talk about what the purpose of even creating an AI assistant for Pulseq even is. First and foremost, there's a lot of difficulties in Pulseq, or not even just Pulseq programming, as we're all aware. You have to have MRI knowledge, you have to have programming knowledge, you have to know how to combine the two different knowledges together. And of course, you have to work with scanners. And there's just a lot of components that you have to keep track of and be aware of. So I have it like in my head displayed like this. There's a learning curve with Pulseq as well. Specifically, you have to, on top of all the other stuff with pulse sequence programming and MRI knowledge, you have to learn the Pulseq package as well. You have to learn how to work with interpreters, which I think is a bit of a head scratcher for us sometimes. And the way that I have to visualize is you want to begin work on a project and you kind of get into this loop where you look for examples and you program. And then when you program, you have to start to debug. Sometimes things don't make sense to you, so you look for expert assistance and then you kind of go perpetually in this cycle. And there are some issues with some of these steps. So for example, if you want to seek expert guidance, so you have questions or you get stuck on something, well, you have to hope that the person is available or that you even know who to talk to first and foremost. So that can take some time. And I'm sure we've had situations where we sent out an email and we're hoping for a response, but it takes a long time and you just want to get work in, right? You don't want to wait for a response. If you look for other examples, that's kind of hard with Pulseq right now, because as far as I'm aware, we don't really have a nice centralized database or some reference material where you can easily look at everything. You kind of have to go through different GitHub repos, go through the official repo, look for examples. It's just sort of scattered. And debugging, this is something that I've been learning when talking to a lot of other Pulseq developers. It's not always obvious what the error even is. Like you write your script, you think everything is good, it makes sense. The plots are looking pretty on your MATLAB or on your Python, and then you actually run to the scanner and it doesn't work, and you don't even know why. So that's a bit of time wasted. And the goal with an AI assistant is to make us live in this bubble here, the programming your work. This is where I think the majority of your time should be spent, where human creativity is most valuable, is when you're actually programming and coming up with ideas and getting the first step going. And then afterwards, everything else should hopefully be more seamless. You should just be able to run stuff. So I'll show a demo in a second, but first I want to do this comparison because people always ask me, like, why even make a dedicated AI agent for Pulseq? Why not just use something that exists out there, like ChatGPT, for example, General Assistant. There's a lot of others, and there's coding assistants as well, specifically for coding, such as Cloud Code, the Gemini CLI, there's recent stuff from OpenAI. The big issues with using general AI assistants, and maybe people have experiences they tried, is that they have a knowledge cutoff when they're trained. So whenever they get released, they're frozen in time, and that's all they know. That's really bad for a fast-paced development environment like Pulseq, where things change often. We also don't even know what the training data is. So a lot of these repos that get updated constantly, or some new repo that gets added for Pulseq, that's not guaranteed to be in the training data. And because of that, there's going to be a ton of hallucinations. And these things are also very confident, right? They want to help you. So because they're so confident, they'll oftentimes suggest things that aren't real to you. And that is annoying if you're trying to use AI assistants for anything. So I'll share a little bit of a demo first just to show what it looks like. And then I'll briefly talk about how it works, just so we kind of have a little bit of understanding. So hopefully you guys can see my browser. Right now I have it displayed like this as a chatbot. It can be displayed in a lot of different ways, but this is something that I use from a personal work. Again, this is just a personal project. You can use it however you want. So if I'm new, I could be like, hello, what is Pulseq? How can I learn to use it? And as it's thinking, what I would recommend, if anybody was to sort of digest this information or think about it, the AI should just be treated as some sort of expert, like a Pulseq expert, someone that is sitting next to you that knows everything about Pulseq, and it could answer any of your questions, no matter how specific or how much level of expertise it requires to answer. So, it's just giving you your general gist about how to dive in, and it gives you some sources too, which I think is really nice because it kind of directs you to where to look instead of just having a general response and then you trying to figure stuff out. You can also ask specific questions like, do you have any code snippets of, let's say, grappa acceleration, right? Let's say you're developing and you want to implement grappa into your MATLAB, but you're not too sure how to do it, or you're not even too sure if examples already exist. So it's just thinking is looking through its database on its backend, and I'll talk about it briefly. And I know I can't spend too much time on this because it's coming up to 10 minutes, so I'll try to go through this pretty fast. But it has all of the Pulseq scripts that have ever been written in MATLAB and potentially future Python, and it can actually direct you and show you examples specifically from code snippets, and you can sort of see what it looks like in reality before you actually do it yourself. So here this is a real example. It found it from it even sources it for you, so it's not making stuff up. You can always go look for it yourself. You can always ask for the source too if you want. And then just to kind of speed it up, I'll ask it another question that could be useful. So let me just stop this because it's going to go for a while, and of course that's something that I can change. But another thing you could do is, can you explain this script to me step by step? I am new to Pulseq. So I just attach a script, right? So a lot of times if you're trying to learn a little bit about Pulseq, you'll oftentimes go through example scripts and just read through the comments on there. AI assistants are really good at helping you out with this. And you could, of course, do this with ChatGPT or any of the coding systems, but they're not going to understand as much about Pulseq as we do because, again, they have some outdated knowledge, or they probably don't even have the in-depth information about the functions. So it thought for a little bit of a while because it's going to spit out a long response, and I won't go through the whole response because we're running short on time. But it's really giving you a step-by-step thing, right? And it's kind of nice because it's able to interact with you however you want to interact with it. So like I see something like MROFs, I'm like, what are the parameters? So maybe you want to use MROFs and you want to know exactly what can go into it. I think right now it's not really too obvious what the parameters of a lot of the functions are. But it knows everything about Pulseq, so it can give you a lot of the parameters and it'll explain what each of them do. And of course, you can ask it as many questions as you want that are custom to you. So I'll just really, really quickly go through these, probably 1 or 2 minutes. Just how does it work? If you keep it simple, and of course it gets more complicated, but to keep it simple, I just took all the code bases that exist with Pulseq documentations, you put into a database, you combine it with an LLM. So you have this combination of generalized knowledge and domain knowledge, and that's how it's able to create these specific directed answers for you. Here's just a snippet of some of the databases I have. So really, this is just subset. I only took a screenshot. There's a ton, right? It has everything. It's harmonized as a lot of the projects that we work on individually, and it's useful because you can sort these in certain ways. So here's like 5 example ways that I sort the data. You have like the API function table, you have like a Pulseq example, sequence chunks, general documentation. And it's useful because then it lets the AI agent be more targeted and more accurate with its responses to you. So if you ask a question like, how do I change my Cartesian K-space trajectory to spiral? You can just ask something as straightforward as that. Like, I just want to change my Cartesian trajectory. It knows where to look because the data is already sorted. something else. I'm new to Pulseq. Can you show me a simple example? Well, there's a example page. It could just pull up something for you that's at the level of your difficulty that you asked. And on top of that, it can do a lot of other things. It's not just the chatbot. So something else that I kind of did with is I just asked it to make a page like this, which just has all the information displayed in a simple way. So I can sort and look at Cartesian trajectories and look at all the projects that has Cartesian trajectories. Maybe I want to look at diffusion sequences, right? Here are some diffusion sequences. You know, you can mess with it as much as you want, just any combinations, but you're able to like very easily just find stuff related to your work. And it made that on its own. I just gave it like a very accurate prompt and did some debugging, but it did it like in 10 minutes. That's like the power of having an AI agent that's knowledgeable about Pulseq. And then just, I'll close on this slide here, just out of interest of time, but I think there's a lot of advantages to having Gen AI kind of work with Pulseq and have those two fields cooperate. And the main advantage is this like snowball or feedback loop here is that AI agents only work if the researchers create the tools and documents. So a lot of the hard work that we have already done into creating helpful resources or very descriptive readmes or okay, you guys can you hear me now? Sorry. Okay, yeah,
Yes.
my headset didn't detect any sound, so it turned off. Yeah, this is the feedback loop that I propose is the most beneficial from using Gen AI. Researchers create documents and tools which we already have. Then you can use a lot of this groundwork that has already been put into Pulseq to create AI. And then if users interact with AI, it's very easy to see where a lot of the questions are directed towards. And from there, you can kind of extract a lot of the common issues. And because we are more sensitive to what are common issues through maybe interact with an AI, then that would help us create more documents or more descriptive situations or examples. And then that could be fed into AI. And then it kind of goes on in a snowball. So I'll end here just with this slide up. I just want to emphasize there's a lot of potential use cases for using Gen AI in Pulseq and in medical research in general. This chatbot thing that I just showed is just one way of doing it. I have others listed here, but I'm happy to talk about any of the technical stuff or any of the ideas at length at a different point. So sorry for going a little bit over, but I'll end here.
Awesome. Thanks so much. Any quick questions for Robert?
If nobody else had the question, so it runs locally, but on your computer, or it's some kind of interaction with the.
Yeah, I had people testing it, so I put it online. I hosted it on a website, but I'm going to be taking that down pretty soon because originally it was just meant to be a fun project, but I think people actually want to use it. So I have to actually make it a bit more robust. My repo is a bit of a mess, so I got to organize that a little bit, and I'll put it back up on a website if anybody wants, but you can run it locally. You can grab it. The only requirement is you have to have an API key with an LLM. So it could be any LLM. It doesn't have to be, I use Gemini, but you can talk with ChatGPT. And all you got to do is provide your key. So a way for it to send information to an LLM, and you can use it locally. Yeah.
Okay. But you need an API key basically, and that's yeah. Okay, I see.
Yeah. The other thing, just to add to that, just to cover all my bases, you also have to have access to my database, which by default I allow. But if people want to use it and there's more users, I'm going to have to be more intelligent about that. So either restrict it or host it somewhere else, because right now it is very much supposed to be like a one-person thing. It was just for me. But if this grows bigger, then yeah. That's kind of where the collaboration, there'd be a lot of collaboration here in terms of how the database would look and how the database would be shared, how we would want to store data, and how we would want to organize the data for something like a general assistant to help out. I see a hand I can answer.
Yeah, is this trained at all, or you just simply use existing LLMs and let it work basically?
Yeah, it's actually not trained. So you can always fine tune it if you want. That is a bit more of an involved process, and it is, I want to say expensive, but not like terribly expensive. I don't think you have to necessarily pre-train to get a lot of good stuff out of an AI assistant. And that's because the LMs that exist out there, they're already very, very good. They're very, very smart, and they're really good at coding. They're really good at answering general questions. The only thing they're not good at is having expert domain knowledge. So they don't really have the in-depth knowledge of Pulseq. And it kind of makes sense because a lot of the stuff we're working on is like cutting edge, or it's stuff that's not really out there on the internet. So when it's trained, it doesn't know about that. So the idea of having a database is just providing it with that supplemental information so that it can make a more accurate assessments when it's answering you. And on top of that, it's enforced to actually provide examples or provide sources when it's answering your questions too. So it's not meant to sort of replace your job as a Pulseq programmer at all. That's not possible, but it's meant to streamline and really focus your work on stuff that matters. So instead of you clicking around through a lot of different repos to try to find what you need or try to find the exact line of code that you have to understand, it can provide that for you. So not trained, but it is supplemented with up-to-date information.
Okay, great. We should move on.
Yeah, I'll stop.
You're ready to share? I got a message. Okay, good.
Hi guys, could you see my screen?
Yes.
Okay, let's
It's
get
not
started.
in full screen mode.
Okay, let me share it. Yeah.
Great.
Okay, cool. So my name is Yuting Chen, and today I'm going to present our work about MIMOSA, multiple metric imaging using multiple echoes with optimized simultaneous acquisition for highly efficient quantitative MRI. Simultaneous multiple metric mapping uses a Taylor pulse sequence to estimate a set of complementary tissue parameters in a single acquisition. It offers high acquisition efficiency and enables a comprehensive assessment of brain tissues. While it also allows for generation of synthetic contrast-weighted images. So this example shows T1 and T2 maps acquired using colors in 3 minutes, which can be further used to synthesize various contrast-weighted images. Several MRI techniques such as MIF and 3D colors have been proposed to achieve simultaneous T1 and T2 mapping. Other techniques such as EPTI incorporate the estimation of T2 star or QSM. However, these methods have not been applied to separate pair and diamagnetic stability sources. So pair and diamagnetic stability sources coexist within individual voxels and conjointly contribute to the observed susceptibility contrast. So to better categorize these components, susceptibility source separation has been proposed to providing additional insights into neurological disease. This example shows a multiple sclerosis lesion, which cannot be identified in the QSM map, but has lower pair and diamagnetic susceptibility values. By acquiring tissue field map from the phase of gradient echo signals and calculating R2 prime from T2 and T2 star maps, both pair and diamagnetic susceptibility sources can be estimated. As conventional whole brain T2 mapping typically suffers from long scan times, limited spatial resolution, and extensive post-processing, the development of an integrated acquisition sequence capable of simultaneously providing T2, T2 star, and tissue field information is essential for source separation. We start from colors, which contains a T2 preparation and an inversion pulse to generate T1 and T2 sensitivity. 5 flash readouts were used to acquire 5 images, and dictionary matching based fitting is applied to achieve simultaneously T1 and T2 mapping. Building on colors, we propose MIMOSA. To encode susceptibility and T2 star information, we replace the last 2 flash readouts with a multi-echo gradient echo module. This allows for configurable echo times and numbers, facilitating flexible protocol optimization tailored to 70 ultra-high field applications. The delays in colors were removed to further improve the acquisition efficiency. So MIMOSA was developed using Pulseq. Following all these acquisitions, images from MGI module were used to estimate both T2 star and tissue field map. The estimated T2 star was subsequently used as prior to jointly estimate T1 and T2 map by dictionary matching. Leveraging the T2 and T2 star information, CAT-subnet was used to calculate QSM and separate pair and diamagnetic susceptibility sources. Transmit field inhomogeneity was also corrected using the B1 map from the turboflash sequence. In EGTR, variable density spiral-like Cartesian sampling trajectory with complementary sampling across contrast was used to enable highly efficient data acquisition. These trajectories rotate across TR based on the golden angle to cover the K-space. Multi-contrast slice zero-shot self-supervised learning method MJSSL with a low network architecture was used to jointly reconstruct all whole brain contrasts of MIMOSA. This approach leverages the complementary trajectory information across contrasts and slices during training, enabling high-quality reconstruction at an acceleration factor of 12 without the need for ground truth reference. So for in vivo validation, the reference T1, T2, and T2 star maps were acquired using the reference methods. Both 3D colors and MIMOSA were performed at an acceleration factor of 3 and 12, and reconstructed using MJSSL methods. The parameter estimation performance was well maintained even at high acceleration factor. For quantitative comparison, 4 ROIs were extracted to evaluate the parameter estimation accuracy of MIMOSA and colors against the reference methods. MIMOSA exhibits better agreement with reduced standard deviation despite fast acquisition. This slide shows whole brain T1, T2, T2 star PD QSM pair and magnetic susceptibility mapping within 3 minutes using MIMOSA with 1 isotropic resolution. To evaluate the repeatability of MIMOSA, a scan-rescan assessment was conducted on 5 subjects with 2 acceleration factors. The coefficient of variation, which we call CV, was calculated across 7 ROIs. MIMOSA demonstrated improved repeatability in both T1 and T2 mapping compared to 3D colors. Intra-class correlation coefficient was also computed with values exceeding 0.94 across all 6 parameters, indicating high repeatability. To further investigate the performance of MIMOSA at ultra-high field application, mesoscale quantitative mapping was performed at 7T with 750 micrometer isotropic resolution, reviewing enhanced tissue details and improved SNR. While diamagnetic susceptibility provide information related to myelin lipids, myelin water fraction offers a direct measure of the myelin water content, which has been used for study of brain development, aging, and myelin-related disorders. However, conventional myelin water imaging methods suffers from limited SNR, high SAR, resulting in low spatial resolution and long acquisition times. Building on MIMOSA, we propose myelin water MIMOSA by incorporating an additional short T2 preparation module and uses a bipolar MGI readout to reduce the echo spacing, so that we can better capture the short T2 component and enhance myelin sensitivity. With all these acquired complex images, the regressometry and susceptibility parameters can be estimated in a manner similar to MIMOSA. While myelin water intra-extra axonal water and free water fractions were estimated by fitting the multi-contrast complex images with a 3-component model. We compare myelin water MIMOSA with reference MCR and GRIS methods and calculate the Pearson correlation coefficient across 70 1-meter major ROIs in 2 subjects to evaluate the linear relationship between myelin water MIMOSA and each reference methods. Myelin water MIMOSA demonstrates strong to modulate correlations with these reference methods and capturing finer structural details and offering higher acquisition efficiency. We are able to achieve all this parameter mapping with 1 isotropic resolution within 5 minutes from a single scan. In summary, we propose MIMOSA for simultaneous multi-parametric mapping, enabling highly efficient data acquisition and up to 12-fold acceleration factor with joint reconstruction using MJSSL method. Despite fast acquisition, MIMOSA achieved high parameter estimation accuracy and repeatability. Whole brain multi-parametric mapping was obtained with 1 isotropic resolution in 3 minutes at 3T and 750 micrometer isotropic resolution in 30 minutes at 7T. Furthermore, we extend MIMOSA to enable myelin water fraction mapping, providing comprehensive quantitative information from a single highly efficient acquisition. Thank you for all your attention, and thanks to all my lab mates and collaborators. I'm open for any questions.
Thanks so much. This is really great. Any question in the last 3 minutes. I have one. This seems like you're really far along with this. Are you ready to share and how other people evaluate and
Oh,
try
yes.
it out? Seems very broadly applicable.
Yeah, so we already like shared some MIMOSA code and reconstruction pipelines in the GitHub, so you can find this link and QR code here. So for mining water part, we are still working on, and I think we are gonna to share it very soon.
Mhm.
Mhm.
That's great.
Thank you.
Okay, I see a little bit of activity in the chat. So if there are no more questions, since our time is up, I think we can call it. So we do have the next meeting on the schedule is December 5th. So let's keep that, and then we can add future meetings. So future meetings will be added to the invite. I'm not sure when I add a meeting. I'm not sure exactly how that will show up for you guys. You may get an email or you may not, but we'll try to do these at this time every month if that works for everyone. And very open to suggestions about any of this. So you know, email us, and thanks to the presenters, and have fun working with Pulseq, I guess. Anything else?
Yeah, I think what I want to say, we were looking for volunteers to present next time, right? So
Yes. So we go with 2 speakers again, or was that too little time for each project? We can probably maybe do less. Less
less.
Pulseq.
I think that the news will kind of we can't develop so far so fast. So I think the news will reduce. I think to at least my guess that two quick talks is probably a better format, and then we can see how we move on. But we'll probably shorten the centralized top-down part.
Yeah, I think there could be, I think the introduction part could be less, and then we can have more question answers from people if they have.
Maybe aiming for more like 15-minute talk or
Yeah.
something.
Yeah.
A healthy discussion. Yeah.
Yep.
Sounds great.
Cool.
Super.
Nice.
Yeah. So we'd love to
Yeah.
hear if you wanna present in December. Let us know.
Exactly. Just drop us a line, and if we don't get many volunteers, we'll reach out to some of you. Okay.
Great.
Right.
Okay. Thanks so
Hey,
much,
everyone.
Thanks, guys. Bye.
See
Weekend.
you next one.
Thank
Bye-bye.
you. Bye.
All right.